Okay, so good night, everybody, and welcome back. We're gonna continue with the second part now, talking about the operations. I think that now we're clear what are polynomials, what do they have, what makes a polynomial be a polynomial, and now I think we should see the operations, right? I understand, Andrea. Andrea.
Hola, Lick, buenas noches.
Hola, Stephanie, qué bueno que ya se integró.
Hasta ahorita me puedo conectar porque mire que no he tenido luz y hasta ahorita también salgo de trabajar, entonces está un poquito complicada la cosa, pero aquí estoy ya.
Excelente, muy bien. ¿Y todo bien por ahí? ¿Todo bien en su casa y su familia?
Sí, gracias a Dios todo bien, Lick.
Qué bueno.
Solo así, sin luz, ¿verdad? Y la lluvia, pero
Sí,
ya, gracias a Dios, bien. Y saliendo de trabajar ya para descansar el fin de semana.
pues me alegra que todo esté bien, Stephanie. Se estaba preguntando por usted
Sí,
y bueno,
sí, sí. Gracias, Lick.
bueno, pues. Muy bien, entonces iniciamos. Voy a chequear la asistencia. Stephanie, ahí está. Carmen Alicia. Carmen.
Aquí, Lick.
There you are. Daniela. ¿No? Kaylin. Lexi.
Present.
Mercedes Alejandra.
Present.
Andy.
Present, Lick.
There you are. Andrea Nicole Miller. Okay. Catherine Nicole.
And
Andrea Nicole Maradiaga.
Here.
I don't understand the message in the chat. What is it?
It's about the Honduras versus Argentina.
Come on. Es mala usted.
No,
mala.
mire que la media hora primera fue de break. Aprovechamos.
Sí, yo quería, pero bueno, hay mil cosas que hacer. Pero así va. Va ganando Honduras, ¿verdad? Qué excelente.
Mejor vamos a la clase.
Okay, thank you. So let's go with now Karen Iracema. Karen Quiroz.
Present.
There you are. Good. Ashley Gabriela. Ana María Celaya. Ana Raquel García. Okay, mi Cintia Valesca. Are you here, people?
Yeah, I'm here.
Okay.
Thank
okay.
you. Sorry.
Okay, I'm gonna call again some of the students. So is Daniela here?
yes,
Okay, Kaylin Vanessa, are you here?
Present.
Oh, there you are. Now Andrea Nicole Miller. No. Okay, Ashley Gabriela Luque. Ana María Celaya. Ana Raquel García García. Okay, Marcela Yulisa.
Present.
There you are. Xiomara Elizabeth.
present, Mister. Sorry, I couldn't be on the first minutes of class because I had a meeting at my work with the parents, and I got caught by the traffic and the rain coming back home. So
Okay.
that's why I was a little bit late.
Okay.
Sorry.
Then we have Eunice Joliet.
Here.
Okay, Gerlin Damaris.
Present.
Tracy Rochelle.
Present, Lick.
There you are. Milagro Carolina. Okay. Maria Daisy.
Presently,
Got it, Maria Daisy. Now Lindsay. Sorry.
sí, María Daisy, no, Liz.
Okay. Lizni Paola. Is Lizni Paola here? Okay. So, checking the second part of the assistance, I think we should be this second part, because it's so important. Now we'll see how to operate polynomials. You may do one activity related with this. Honestly, there is one operation that practically summarizes all of them, and it's the division. That's why the division is gonna be like last thing. You're gonna complement that one with some tutorial videos, and there will be an assignment for the next Wednesday at most. It will be like the last day we have to present those assignments, okay, until Wednesday. The photo you were asking me right now in the group, it was like from today, because today we start the class, until the Monday at 11 p.m., right? At 11 at night. So be careful with this. Don't let the pass time. Then I have to present the report of your score this next Thursday. Yes, this next Thursday, 28 September 29th. And I think this will be the closure of the course, of the class. Remember that tomorrow we will have time in the afternoon to work in the projects, okay? You will present me the project tomorrow. I hope you already finished this one. I hope that today you have like chance to perform some of the things that are missing over there. And that way you will present it tomorrow in the afternoon, okay? I will change the schedule, and the schedule will work just like 20 minutes per group. It will be just like this, and it will give us a little bit of time, okay, to work in the afternoon for you to like perform those things that are missing. Guys, I think 2 weekends have been passing, and since last week that you have everything clear, that many of you already translate the words or the contents, which is the word that at least you did the last time, and all that you have to do now is organize it, right? I think that you already organized it too. So it will be for tomorrow. We have it since the beginning of the class, okay? So we'll give you a little bit of time, I think like from 1 to 1:30, and that way we will start like 1:40 and 20 minutes, 20 minutes, 20 minutes, every group presenting the project. There will be a specific meeting for every group, okay? In this case, I will share the link as we did it the last time, just that the meeting will be lesser time, okay? Remember that at the end is just match the contents, the unmatched ones in a list, the unmatched ones of the books in the list too. So it's simple. It's simple. The job you have to do is simple, and the questions I will do about it will be simple too. Okay, kind of like see the amount of topics you have over there. So you should like count those. You count the amount of topics you have in the book. Count the amount of topics you have just in the curricula, but not in the book. This is so important moment to make a, how can I call that? The adjust of the contents of our national necessity with the curricula of other countries. So let's start with the polynomial operations. In
I'm
this
sorry,
case,
I have a question.
you have a question,
I'm sorry. Yeah. You said you were mentioning Wednesday. What is for Wednesday?
The assessments.
Oh, right. All right.
The
Okay.
assessments. So you will
The ones
focus.
that were for today are for Wednesday.
Yeah, the assessments of the weekend will be for Wednesday.
All right. Thank
And
you.
remember that it's a teamwork, so you should organize with your teams to solve those exercises. Okay, I think is just organize yourself, which is one of the most important competence we must have as teachers.
All right. Thank you.
Okay. And tomorrow we're gonna have the project, which is 30 points. So remember, okay, it counts. I mean, part of the evaluation was already made. I mean, out of these 30 points, were evaluated the last time that we had the meeting. And now I think we're going to conclude with those 30 points tomorrow. Okay. So Let's start with the polynomial addition and subtraction. And I'm teaching those at the same time for one simple reason. At the end, you have addition and subtraction of numbers. And it's so weird that when we work real numbers, we may have situations like negative 20, for example, minus 10. What is the result of negative 20 minus 10?
Minus
Negative 30.
It's negative 30. It looks like you make an addition of those negative things, right? What is the result of negative 27 plus 13?
Negative 14.
Negative 14. You're right. So at the end, in addition or in subtractions, you do the opposite thing. So at the end, it's not about add and subtract polynomials. It's about join them. Okay, so at the end, that's what we will do. Join polynomials. We will see how. So the principles that we study for addition, subtraction in real numbers will work here in the polynomials. So at the end, add or subtract polynomials is practically add or subtract real numbers. Can you add 2 plus 9? Of course. We know the result of this will be 11. Then, can you add 2x plus 9x? What do you think will be the result?
7x.
11x, right?
Yes, 11, sorry.
If it's a subtraction, then it will be 7x, but negative if it's 2x minus 9x. So at the end, is the same idea we did, just that we're adding this part of work with the variable x, or the variables we're working over there. Question to you, is it possible to operate 2x squared with 5x, and what will be the result?
No, you can't.
Why?
Because if you need to add the numbers that have the same degrees.
Okay. So you know something about the topic, it's true. There is a little condition for this one, but there is a mathematical, well, a non too much mathematical reason to do it, to add them. It's related with math at the end. Question then, is it possible to add square units with a segment of a shape, for example? And what will be the result of this? I mean, this 2x squared is representing an area. And this 5x is just representing a segment of a side. Can you add those? And what will be the result of this? It doesn't have any sense, and that's like the main reason. This is representing right now square units, and this is representing right now linear units. At the end, this one has exponent 1, the other one has exponent 2. So the clue or the main tip to solve this addition subtraction of polynomials is focusing like terms. So what are like terms? Like terms are expressions, are variable expressions, and in general, right, variable expressions with same variable, but that variable or variables will have the same exponent. If they don't have the same exponent, they are no like terms. They can have the same variable, but as you can see, one variable can represent different things. One variable can represent area, or one variable can represent the measurement of one side. Different things. So that's why they must have the same exponent to put those in the same context. That's like the main idea. So here you have a list of like terms examples and list of unlike terms examples. Like terms like 2x and 19x, which at the end, the job to join them is just focusing to add the 2 and the 19, and then work with the x they are working with. It's like add 10 centimeters with 12 centimeters. Yeah, at the end, this is 22 centimeters. But the question is, can you operate, I don't know, 10 kilometers with 20 pounds? No, right? That's something impossible. And essentially is because those things are not the same kind. It's what we teach to the children, just that now we variables, okay? It's like you ask the students, how many red apples do you have in a bag? And how many green apples do you have in a bag? They will not ask you or tell you the total amount, right? They will tell you the one with a specific characteristic. Is what we normally do. So here you have a little idea of how the like terms and unlike terms are. And essentially, this is what we will join. And I'm not saying add or subtract, because sometimes you will add, sometimes you will subtract. Okay, so here comes an example. And to add or subtract polynomials at the end, what you will do is combine the like terms or join the like terms. Operate next polynomials. For example, I have the polynomial. What is the degree of this polynomial, of the first one that I have in those red parentheses?
3.
So what is the name of that polynomial?
Five.
The name, I mean. How we call it?
Trinomial, right?
It's a 1, 2, 3, 4 monomial. So it's called polynomial. And it's the degree 3. So what is the name?
Cubic.
Okay, so that's a cubic polynomial. The other one too, it's a cubic polynomial. Sometimes you don't have the same kind of polynomial, right? The same classification or the same kind of polynomial, you don't have it. But what you should do is see if they have like terms in common or not. And this will be possible just if the two polynomials you want to add or subtract, depending the operation you want to do, works with the same variable, and of course, those variables with the same exponents. Okay, so check this out. The way to solve this is make something that we call and teaches normally like the horizontal method. In the horizontal method, will require that you list those elements of the polynomials separately, but there is a little situation. For example, here, with this first parenthesis, with this first polynomial, there's no any trouble because there's nothing multiplying that parenthesis. And normally multiplication or addition, subtractions of polynomials will require those parentheses, even in the division, because we must specify who is the first polynomial and who's the second one. And it is because the negative sign here will do some changes too. Well, I'm showing you a case of subtraction because the case of addition is so similar. And when you have an addition, practically you don't make many changes. So you will see what is the trick of the horizontal method. So the first polynomial, because it's not being affected by anything, at the end is just like free each of these things or each of the monomials we have inside these parentheses like they are. Now, to do the same with the other one, you should do something first. And is that this negative sign, it's practically affecting all of the signs inside the polynomial, okay, or inside the parentheses. How this property is called, do you remember?
Distributive.
As the distributive property, okay? One of the properties that you explain so good in that photo. So here we go. And this distributive property do many changes. As an example, this positive m to the power of 3, because of that distribution with the negative sign, changes into negative. So negative m to the power of 3. This negative 4m to the power of 2 changes to positive. Essentially, what I'm doing is multiplying the negative sign by each of the elements inside this parenthesis. So this one that was negative becomes positive. And why that happened?
It's
If you
math
don't remember,
rules.
there are some rules. Excellent. There are some rule of signs that we should remember, and especially these ones of the negative ones. For example, if I have negative times positive, it is negative. If I have positive times negative, it is negative. If you have positive times positive, what happened? Well, nothing happens. Stays positive, right? If we have negative times negative,
Positive.
interesting. This becomes into positive. So those are the rules we may use a moment to work with this one. So good that you remember those rules. So negative times positive turns that 2m into negative 2m. And finally, the negative times negative turn that 1 into positive 1. If you see that minus, this negative sign makes some changes in here, right? You see it?
Yep.
Okay. So now it's the moment to identify the like terms. Do we have a like term for 2m to the power of 3? Do we have a like term for the 2m to the power of 3? What do you think?
Negative
Yes.
M3.
Excellent. It will be the negative m to the power of 3. So we may try to work those because those are the ones that are like terms. I mean, what is 2m minus 1m to the power of 3?
1M to the power of 3.
Excellent. So practically here we have the first result. 1m to the power of 3. You don't need to write that 1, we say. What about the 5m squared? Do we have a like term for this one?
Yep. 4m2.
Squared. So to join them, all that we have to do is work the 4 in the 5. I gave you the answer. So it will be
9.
9m squared. If you see, I'm just adding the coefficients. So let's go with the next one and see then what happened. Do we have a like term for the next result? I mean, for the next number, which is negative 4m?
Yes.
Negative 2m.
Negative 2m. And if I join them, what will be the result?
6M.
Negative.
Positive 6.
M.
Wait, positive or negative?
Negative. Because
Negative.
Yes. At the end, I'm not multiplying them, right? I'm just joining them. So you have to like two negative things. At the end, the result will be a positive. And I think we have here the independent term of the two polynomials we have. And those are like real numbers, so we can get the result so quickly.
12.
What is 11 and 1?
12.
12. So let me tell you, this is the final answer of the exercise. You already add or subtract polynomials. At the end, it's just focusing the monomials that are like terms. So each monomial will have a like term. Sometimes, if it doesn't have it, well, just copy it. It's just like it's like when you add by 0 or when you add to 0. This stays the same. Okay. So this is called the horizontal method. And there is another one, honestly, not the best for these cases because the vertical method is working more when you add polynomials. But I want to show you how this works because maybe that's in the division, we will use a vertical method essentially. So if we have here 2m to the power of 3 plus 5m squared minus 4m plus 11, and we want to subtract this with m to the power of 3 minus 4m plus 2m minus 1, we must be careful with something. It means that this negative sign will affect the second expression. Okay? Will affect the subtraction, if you remember the elements of the subtraction. It's like when we work this one. So check this out. If I have 102 minus 101, I can get the result focusing the order and respecting the order of the position of the hundreds, the tens, and the ones. And of course, I think that everybody know how this subtraction works, right? You subtract the ones with the ones, the tens with the tens, the hundreds with the hundreds, okay? The same idea here. You will subtract the m to the power of 3 with the m to the power of 3. You will subtract the m squared with the m squared, and I didn't copy the m squared over there. Then you will subtract the m with the m and so on. So that's like the main idea of the subtraction. But careful here, because many people confuse over there. What is 2m to the power of 3 minus m to the power of 3? 1m to the power of 3. What is 5m squared minus negative 4m squared? Be careful because there's a minus minus situation. It means that this becomes, and that's why this method is not the best this way. But at the end is one method we can use too. So it becomes like plus 4. So at the end, this is like plus 9m squared. Don't know if you got it. With subtraction is a little bit tricky. Okay, but be careful. What about the next one? The same. This
Negative 2m.
Excuse me?
Negative 2m
The next one.
is the next one.
Negative 6m.
Is it negative 2 or is it negative 6?
Negative 6.
Negative 6.
Well, that's why we have to be careful, right? As we operate here, the ones with the one, the tens with the tens, the 100 with the hundreds, being careful into doing that process as well. Same is happening here. We may work the subtraction of the 4m minus the positive 2m. It's practically do these. Negative 4m minus positive 2m. What a problem. And this is the problem we may see with the vertical method. That's why my suggestion is solve it with the horizontal method. It's better. I think so. So at the end, this is negative 6m. Try that one. It's like work negative 4 minus positive 2, which is negative 6. And finally, something similar here. You have positive 11 minus negative 1. This minus negative 1 will turn that into an addition. That's why it's so crazy to talk about addition or subtraction here. Answer will be 12. And it have to be the same answer, of course, because it's the same exercise. So what method do you prefer is your decision. Okay?
The first one, absolutely.
Absolutely, yes, you don't get confused, and that's why I told you normally the teachers work bless you. The teachers work in this method horizontally, right? It's like the best one. It's more organized. You don't have to confuse yourself. The other one works when you make additions, honestly. It's so good to work the vertical method when you work addition, but it's not the case. So which one is better for you? I think this one. Not too much that one, but at the end you decide. Okay, so this is the addition subtraction of polynomials. We may try some exercises later. Any question about it? This just combine the like terms. That's like the secret of this addition subtraction. Of course, the thing of the sign is needed and so important moment to make subtractions especially. Okay, so if there's no question, let's see next operation, which is the polynomial multiplication. The polynomial multiplication required that we remember some rules of exponents or properties of exponents, the multiplication of real numbers, and especially the rule of the signs that we say a few minutes ago. So the exponent rule works like what happened when you have the same base of the exponential expressions. I mean, what happened if you have 3 to the second power times 3 to the power of 4, for example? It will be the same as have 3 to the power of 6, because at the end, they have the same base. It's an exponent property, I think, that everybody knows. And this simple rule will help us to understand how the variable multiplication works, the variable multiplication. The other property, which are the rule of the signs, will be useful. The ones that we use in the last exercise will be useful here a lot because we're going to multiply. And of course, how to multiply real numbers too. But we don't have problems with this because we can use the calculator, right? So what will be the result, or what do you think will be the result of negative 2m to the power of 3 times 4m to the second power?
Negative 8m to the power of 5.
Okay. What you will do is multiply the coefficients with the coefficient, because there's no way you multiply a number with a variable not knowing the value of the variable. And then you're going to multiply the variables with the variables. Of course, the same idea. You will not know what to do if you don't know the variable correspondence number. So in this case, I'm agree with you, negative 8m to the power of 5, because all you do is work this way. And let me tell you that if we understand how to multiply those simple things, at the end, multiply polynomials is do many operations of this ones. So is there any question about how to multiply monomial times monomial? It's so simple. Any question about how to multiply monomial times monomial?
Not for me.
No.
No? So let's see now how this becomes interesting. So I want that we put in practice these ideas, but first of all, try it. Try these 4 exercises. What do you think will be negative 12b squared times negative 3 to times b, or negative 3b to the power of 1? Then what is 5g squared h and 3ah? Well, try it and then tell me the answers. So who can tell me the first answer? I think we can make this a little bit funny. So I prepare here a roulette, and I think that we may answer if it's our turn. So let's see if I can open it. Give me a second.
I just copied the first one.
Oh, really? Okay. Okay. Sorry. I'm gonna show again the presentation, and there you have it. To try to copy the 4 exercises, because I think we can answer those mentally. You don't need like to show process. You just have to focus in the rule, which is essentially work the coefficients with the coefficients and the variables with the variables. Remember, the variables must have the same base. I mean, they must have to be the same. Okay, let's see. Are you ready? So I'm gonna make a roulette. I want to hear your participation. Same time, I'm gonna check your solutions. Okay, here we go. So here we have that roulette. You may see, you already see or use on internet in those virtual classes. And yeah, I have everybody here. So I hope that you answer. Let's see. Let's see who's gonna answer the first one. Okay, it says Daniela Abigail. Are you there, Daniela?
Yes.
Could you tell me what is the answer of the first one? If you can't tell me, you can write it. You should. Because I saw you could write over there. The answer of the letter A. Wow, honestly.
Because my internet's not great, so I cannot really see the image. So that's why.
Okay, but I think you can hear me, right?
Here.
Okay, what is the result of multiply? Negative 12b squared times negative 3b, for example. What do you think will be the result? Or no idea?
No idea, sir.
Okay. So let's listen because If there's a problem, there's an issue with the internet, okay, I got it. But then you should watch those videos because remember you're gonna have a test this weekend, this Sunday about this one. Okay, so let's see. Let's see who's gonna come now. Trying to solve the first exercise, which is so easy. Okay, we're gonna give the chance now to Lisney Paola. Can you tell us the answer of first exercise? No? Okay. So the answer first exercise, I think you know it. It will be a positive number and it's positive 36b to the power of 3. Okay, what about the second exercise? Don't know if somebody can tell me what's the answer of the other one.
I have it.
Uh-huh.
15 AG. ¿Cómo se dice la 2?
Square.
Square.
Uh-huh.
AG square H square.
Okay, you got it. Why h is a square?
Because I have 2 G's and I have 2 H.
Well, you have just one g squared, but the h, my question is why h goes to the power of 2?
Because I have 5G square H multiplying 2,
Just
sorry.
the h. Why the h goes with the exponent 2? That's the question.
I have 2 H's.
Okay, because this is h to the power of 1 and this is h to the power of 1.
Yep.
It's like add 1 plus 1, that makes 2. Okay, who wants to answer next one? So good, Andrea. Who wants to answer? Xiomara? You raise the hand? Honestly, I don't hear you. I can hear you, sorry. Don't know if Maria Daisy can help her. No? Well, in this one, we didn't have the coefficient, right? So the coefficient's practically 7 times 1, which stays like 7. Then,
español,
the x to the square,
7x a la 9, y a la 3.
yes, x to the power of 9, y to the power of 3. What about the next one?
8
Who has
y
the
a
answer
la
of
2,
next?
5.
8y squared, and just that?
Negative 10y.
Okay, minus 5 or
Negative
8y
10y.
squared minus 10y. What is the answer?
Minus 10y.
Okay, why?
Because you're multiplying the
Oh, yeah, but
y times the 4 and then times the negative 5.
So practically this 2y will multiply each of the monomials inside the other polynomial, right? Yes?
Yes.
Yep.
Okay,
Yes.
so if it's like this, let me tell you that you already know how to multiply polynomials. Yes. At the end, this is how you get multiplied polynomials. There is a funny way that England people use, so this is not the answer, be careful. And it's that they work like a kind of box. They decompose the number, or the polynomial, I mean, and even with numbers, they do this, into like the parts that make it works. For example, in here, we have the 4y and the minus 5. And essentially what they do in order to get the result, it's multiply all the elements together. Of course, this is called the box method. So you should make like 2y times 4y, it is 8y squared. And what is 2y times negative 5? There's no variable here, but it has a coefficient. It's practically multiply the 2 and the 5, which is making negative 10. Of course, that's the answer. 8y squared minus 10y. interesting thing about the multiplication of polynomials we're going to see? Yeah, those are monomials. The first case, the second case, the third case are monomial times another monomial. But here I have a monomial times a polynomial. And essentially, when you multiply polynomials, matters that you know how to multiply monomial times monomial. It's so easy. So let's see how to do this job. How can we multiply some polynomials? For example, this case, as we say, we should apply the distributive property, which consists in to multiply this monomial times each of the polynomials we have, times each of the monomials we have in the other polynomial, or in that specifically linear binomial, right? So at the moment to multiply the monomials, all that we have to do is use the properties as we learn it, okay? It is so simple. And here is the property. Is it clear now why the answer is 8y squared minus 10y, not minus 5? Okay, be careful with that little detail, and let's go with now the interesting part, right? What happens if I have the product of two binomials? How can I do that? Who has an idea?
With the distributive too.
But what should we distribute? That's the question. Agree.
2x.
With the x plus 4 and the negative 2
With the x plus 4.
4. So essentially, we have like kind of multiply everything with everything. It's kind of what we will do. With the box method is very easy to see. For example, the first binomial is made by 2x and negative 2, right? This is what England people normally uses, as I was saying. And the other one is made by x and positive 4. So all that we have to do, like I said, it's multiply everything with everything. In this case, we're gonna multiply the 2x with the 2x with the x, which makes 2x squared. The 2x with the 4, positive 4, which will make 8x. Agree?
Yes.
Yes?
Yes.
Then we go with the negative 2. The negative 2 with the x makes negative 2x. The negative 2 with the 4 makes negative 8. So as you can see here, we have like the answer, but not yet. Something interesting happened in these exercises, and is that we will be on one simple need, because there is something that is not correct in mathematics, especially when you repeat things. As you remember with the sets, something like that in here. Of course, the distributive property will work, like we say, the 2x with the whole polynomial, and then the negative 2 with the whole polynomial again, as we see it over there. Then we have to apply the distributive property from each of these ones. The 2x times the x, the 2x times the 4, what we did over here. And here the negative 2 times the x, the negative 2 times the 4. Okay, there you go. So practically we have 4 multiplications of monomial times monomial, which is something we can do mentally, I think so. As you can see, we have the same values over there, but be careful because those values here cannot stay separated. Why they cannot stay separated? Why cannot be this the final answer? Because those are like terms, and we cannot leave it like that. One common mistake is called this one like a quadratic polynomial, when it is a quadratic trinomial, because it will have just 3 terms. At the end, this 8x, and tell me if you agree or not, and negative 2x makes 6x, and this will be the final answer. You got it?
Yes.
Yes.
Okay, so be careful with the little details, and that's why we go with addition, subtraction first, because multiplication will require that you apply like terms once, and something like that will happen division. So we are almost there. Any question about it?
No.
No. Okay. So we're going well. And here we go now with the last operation. Then we'll do some practice because that's what we want to conclude today, the polynomial operation. The assignment is about this topic, the polynomial division. Like I told you, the polynomial division mix all the operations at the same time. Not the one that I will teach you here, the one that we will see in a Jamboard that I prepare for you. So let's see how this one works. To divide polynomials, essentially, you will work the same idea as we did it with the multiplication. Well, we're going to start with the case when we work with a division of monomials. That is not always like that. So, as we have some rules for the multiplication of polynomials, we have some rules for the division of polynomials. And here we have the example. We can rewrite this expression like next one. Essentially, the word of divide monomials by another monomial is to, or consist into, divide the coefficients and apply next rule with the variables. As we saw, when we multiply exponent expression that have the same base, you add the exponents. When we divide exponent expression that has the same base, you will subtract those exponents, okay? It means that the final answer of this one will be
4x
to the power of?
the power of 3.
Excellent. That will be the answer. That will be the answer, okay? 4x to the power of 3 is the final answer. And of course, this is when you work dividing by a monomial. In the other exercises of multiplication, we don't have the trouble because at the end, the exercise of multiply one polynomial times another polynomial consists into multiply each of the monomials of my first polynomial with the other monomials of the other one. But here with division, it's not always like that. And that's the interesting part. So here we go with another case. And what happened if we have a very specific exercise like that one? As you can see, like I told you, the parentheses are so important in those exercises. And yeah, the way to solve this one is divide. It's not a distributive property, be careful. It's divide each of these elements that we have over here by this monomial that we have over there. Yeah, it's a kind of separation. It's a kind of representation like fractional expressions. And the job here becomes so simple. Not always simple, because sometimes we conclude something that is not a polynomial. That's why the polynomial division, it's very tricky. Well, as you can see, this will be the answer in this exercise, right? If we divide that 2x to the power of 4 with this one, the negative 8x to the power of 3 with 2x squared, and the negative 6x squared with 2x squared, we may conclude the next answer. Is it clear how to divide by a monomial? Because the rules are very simple. You got it?
Yes.
Yes. Are you sure?
Yes. Yes.
Okay. Because here comes like the interesting thing of today. How can we make a polynomial division? Not a polynomial by a monomial, which at the end, it's so easy. But when we have a division that goes in this way, we have to make a weird procedure. Honestly, that's a procedure related with the long division of numbers, and there is another way to divide polynomial that is called the syntactic division. So we have those cases or those procedures, the long division and the syntactic division. I will explain you these in the Jamboard activity we're going to do, because we're going to make some exercises in order to like conclude and have a clear idea of all the the elements, the characteristics of the polynomials, and the operations of polynomials. But this topic, because it's very huge, will be part on your hands too, okay? So I will evaluate more, I will evaluate this more in the assessment than in the test, because it's a topic that I think one exercise of this one can take very long time, okay? So we're gonna start with the Jamboard activity today. I hope that this time you have the chance to participate over there. And like our notebook, it will be like our notebook that we will use during those classes. So let me share the window of the Jamboard, which is the same as the roulette. And let me share the Jamboard link. So again, you're gonna have editor permission. Just please do not erase anything of the presentation, of the Jamboard that I'm showing you here. Here is the link. You should connect to connecting. And let's start doing these exercises. To do the exercise, I think that we will make like a kind of raffle. We're gonna use the roulette. So try to answer, please. Try to answer when I call you, okay? So I will ask you first to determine the degree of each of the polynomials. So we're gonna write here DEG for degree, and I will appreciate if you write that degree next to it, depending if it's your turn. So let's see how the roulette works again. Are you ready? I think you're watching the exercise. Just wait for your turn. Okay, let's see who's gonna participate right now. For the degree on first exercise. Okay, so Andrea Miller, tell us what will be the degree of the first exercise, please. No idea? Andrea Miller, are you there? No? Okay, let's go with next classmate and maybe we'll try it. Ana Maria Zelaya, can you tell me the degree of the first one? If you can write it, at least tell it me.
She's having problems with the internet. She wrote it in the chat, I think.
Oh, really? Oh, I couldn't see. That's why it's better the class in the university, I think so, because of these troubles. So the degree is 3. What about the second one, letter B? Let's see who's gonna answer. Also, Cynthia, can you tell us what will be the degree of the letter B?
I think it's 2.
Is it 2?
Yeah, I guess.
7 or am I confused?
4.
Is it 7, 4, 2? Wow, we have many options. 4, 7. What it will be?
Oh, I don't know. Let me see.
Who thinks?
4x, right?
Why is 4?
Because we have 4x.
We have 4 x's, but at the end, it's not about the amount of x's you have over there. It's about the greatest one. I think so. Just that there is a little detail with this exercise. And I'm checking if you pay attention on detail, because at the end, teach mathematics is about this. It's about being careful with the detail.
Well, I think it's 2 still, because it's the more value that the x has.
Okay.
I think that is 3.
Uh-huh.
3 too.
Okay, 2 students saying that is 3. So 3, why 3? Of course, you must be sure about your solution, your decision, sorry, and your solution of the problem. Because there is a little condition that we have to focus on. Somebody's trying to show something. What is the degree of that expression? We'll do something. We'll do something. What is the degree of 3x squared and y? What is the degree? Just of this one.
3, because x has a 2 and y has a 1.
Excellent. When you work with more than one variable, okay, when you work with more than one, listen, when you work with more than one variable in the monomial you're working, you will add the exponent they have.
Okay.
So the degree here is 3. What is the degree of this one?
So it should be
2.
It's 2. What is the degree of that one? Well, the degree of that one is 1, and the degree of this last one is 0. So I'm totally agree with you when you say the degree of this polynomial is 3. I think that is what Karen was trying to tell us here, circling this expression over here. Okay, Karen
Okay,
Q.
thank you for letting me know.
Excuse me.
Thank you for letting me know.
Okay, so now you will never forget it, right? Be careful with those answers. Be careful with those answers. Okay, let's see who's coming to, or who's gonna tell us what is the degree of the next one. But I think you got it because we tried one similar to this one. So similar. So, okay, we're gonna listen. Miss Marcela.
2.
It's 2, right? It's 2. So let's see who's coming now for the last one. What would be the degree of the last polynomial? And it's Milagro. Milagro, what is the degree of the last polynomial? Is Milagro here? No? No. We're gonna give the chance to somebody else. Well, don't know. Can somebody tell me what is the degree in that exercise?
5.
I think it's 5.
Uh-huh. And the rest? It's 5?
Not a polynomial.
Okay. My question doesn't have any sense because that thing is not a polynomial. I'm sorry.
You
Okay.
catch us.
Yeah.
Two
Excuse me?
degree of this.
Letter D. Well, let me tell you that the question doesn't have any sense because this is not a polynomial. So your first question, or the question you have to do to yourself is it a polynomial?
Yes.
No, because of that letter P. The letter P is going on the denominator. And I show you like two situations where something is just an algebraic expression, not a polynomial. So it doesn't have a sense to talk about degree if this one is not a polynomial. Okay?
Okay.
So
Thank you.
something like that happened on the test. And I don't know why sometimes you just do mechanical things. In mathematics, we don't do it like that. And I'm preparing teachers, so that's why I do things like this. In one exercise of the test that I ask you to try a geometric sequence, the last Sunday test, wasn't a geometrical sequence, right? If you answer like that, wow, immediately I give you the points. Because it's true, it wasn't. Or if you solve it as a arithmetic sequence, you got it, because at the end it was an arithmetic. It wasn't any geometric sequence on the test. Okay, so something like that happened in this exercise. That same situation. So do not fall in trap again and again. Teach mathematics is about remember those little details. That's why it's uh, it's a challenge teach math sometimes, right? Because we must focus in all those details, have a good memory. Okay, now we already know what is the degree. We already know the amount of term they have. So please write the names. I think you know how. And remember to write your name and your number list. That way you're gonna count some participation points that are practically we are going to conclude those tomorrow in the morning. And tomorrow I will give you like the new schedule to work in the afternoon, right? To present the project. Could you write the name, please, of the polynomials we have over there? Oh, there you go. There you go. Remember to put a name and last name, right? Because we can classify it depending the degree and depending the amount of terms we have. Okay, there you go, Eunice. So good. That's a quartic polynomial. When is called quartic? Do you remember?
Wait, sorry.
I think
It's a
it's another.
cubic.
Ah, okay. You got it. You got it. So let's fill it over there. You can write the other one, no problem. Okay. And you're right. It's so simple like that. So it's a cubic polynomial. You're right. Now the second one, what it will be? Letter B. That's a cubic polynomial. You're right, Miss Marcela. You're right. So good. So good, Marcela. And many people working the other ones, right? That's so good. It's a quadratic polynomial. The letter C, right? It's a trinomial, Nicole. But what's the other name of the letter C?
Oops, sorry.
Andrea, Nicole. I mean, it has another name. It's not just trinomial. That's not enough. So we may call it like properly, right? Like the name they have. It's so good. There you go. Cubic polynomial, the other one. Nice. So this last one will be a quadratic trinomial. Thank you, Marcela. You're right. That's the answer. That's so good. Maria Daisy too. You're right it over there. Okay. So we may go to the next page. In the page number 2, you have some operations. You have an addition and subtraction, and I think we're gonna do a little raffle to see who's gonna make the addition with the roulette. So we are at page number 2. Ana Maria Celaya. Are you there, Ana Maria?
Present Mick, is that I have internet issues and I think that and I don't have like good internet right now.
But can you see the screen?
No, I cannot
Okay.
see the screen.
Okay.
I,
That's got
I
it.
see it all black.
Oh my God, what a problem.
Maybe they can send me a picture.
I will do it. The WhatsApp, right?
Yes.
Not the way, but there he is. I'm asking you to solve the letter A. At least like dictate to me the answer, please. And we're gonna advance with letter B since Ana Maria tried to solve the letter A, I think, with what
Yes.
you have been listening. I think you get it, or you will show us like what you understand,
Okay.
because I'm exploring this too. Well, let's see who's gonna try the letter B. Thank you, Ana
No.
Maria. Here we go, letter B. Stephanie. Stephanie.
Nick, can you send it via WhatsApp so I can solve it because I don't have the Jamboard. I'm on the phone since I
Okay,
just left work.
already there. Already there in Fundamentos de
Okay,
Matemática in our
I'm going
group.
to send you the answer over there too.
Please, letter B.
Okay.
Appreciate a lot that we're using the other tool too, the WhatsApp group. What about letter C? Let's see who's gonna make that multiplication. Let's see who's gonna make that multiplication. And the same, right? If you don't have the chance to participate here, you can do it with the WhatsApp group. Okay, it's gonna be Xiomara Elizabeth. I don't know why it's so my God. And I think you have troubles with the internet too.
I'm a.
Am I right?
I don't know if you can listen to me right now.
Yeah, I can listen yourself.
Okay. Letter C, right?
Yes, if you can tell me the answer.
Well, I did the distributive property, so that means that I multiply 2x times x to the 2, and that is 2x3.
Excellent.
Then I multiply 2x times 10x, that will be 20x2.
Uh-huh.
And then I multiply 2x minus 1, and that will be 2x.
But positive or negative?
That will be negative.
Okay.
Minus 2x.
The sign is so important. Do not forget the sign. What will be the sign of the second multiplication?
Oh, it will be 2x3 plus 20x2 minus 2x.
Okay, you got it. There he is. Number of the list, please, Xiomara?
Is 17.
17. There you are. So sweet 17s to you. Let's go and see who's gonna solve the last one. The last one have something interesting, and is that you will apply distributive property twice. Let's see who's gonna make it. Maria Daisy, again, you have a second chance. Maria Daisy, are you there? Does she connect at the end or not? Oh, there you are, Maria Daisy. Can you tell us what will be the answer in this exercise?
In the letter C, letter C.
Letter D.
Letter D.
Yeah. Can somebody answer letter A, please, and letter B? And remember to leave your comment, your name with.
I think I have the answer to the problem you gave me. I think it was B, right?
Yeah.
B. I think it's x3 minus 5x2 plus 5x minus 12. I think that's the answer.
X minus
x3 minus 5x2 plus 5x minus 12.
Minus 12.
Yes or no?
12. Oh,
am I correct?
I think that you saw number 9 over there, like number 4, but
it's a number. Yes, I saw it as a number 9.
It's a number 9. Yes, and that.
No, I saw the number 8 as a 3. That's why.
Oh,
the first one I wrote 2x3 plus 5x minus 3, and it's an 8, right?
It's a 8. Just that it's like.
Yes, that's okay. I'm gonna solve it again then.
But you solved another exercise, and it's okay. So good. So you got it.
Yes.
I'm
sorry.
No. You did it so good.
I don't have my eye. Están mis ojos cansados, mister.
I understand yourself because I'm working virtual classes all the day too. What's the number of your list, Stephanie?
Number 1.
Number 1. You're the number 1, so there you are.
Yes.
Good.
Thank you.
Nice. Okay. And at the end, who was trying to solve the first one? I forget it.
Me, Anna Zelaya.
Anna, and what is the answer you got?
Well, now that I see Nicole's, I do not think that I have it right.
Okay.
But the thing is that the answer that I was having is x cubed plus 5x minus 9.
X cubed plus
5x
5x
minus
minus 9.
9.
Okay, how do you get x to the power of 3?
Well, I was adding x squared plus x. So
Can you add x squared plus x?
no,
Are they like terms?
no.
No, right? So we can't.
Yeah, sorry. So it will be x squared plus 6x plus minus 9.
Minus 9. Okay, it will be x squared plus 6x. And what is negative 7 plus 2?
Negative 5.
Negative 5. Okay.
Yeah.
Huh. Uh-huh.
Sorry. That
You got it now. You got it now.
okay.
Okay, so it was Ana Maria, right?
Yes, number 13.
Number 13. Okay, that's so good. So I think we're like trying to perform those little ideas, and do not get confused multiplication with addition, right? That's why what normally happens with students, and it is because of those details maybe the teacher doesn't say. Of course, I mention it. What I probably do in my classes, or what I normally do in my classes, that I paste memes or post-it related with no like terms or like terms and things that you may work with. Okay, that way students see it in a different way. Who's solving the letter D? Still waiting for the answer of the D. You have it, Sumara?
Yes, I have the answer.
You have it? Okay.
Is x to the power of 2
Continue.
plus 2x plus 1.
X to the power of 2 plus 2x plus 1.
Yes.
Wow, you got it so good. You got it so good. And it's true, that's the answer. So you have twice participation here. You got it? Let me tell you, there is something special about this last exercise. What happened when you multiply a number itself? For example, the 3. If you multiply itself, you make what? Tricky, Karen, tricky, Karen. Honestly, it is something that I was wondering you show me. I was wondering somebody show me this in this last exercise. X plus 1 to the second power, which let us understand that this exercise is following something special. And that's what I want to show you with 3 times 3. You're going to tell me is 9. Well, I'm going to tell you is 3 squared for what Karen showed us. What you'll build in here when you multiply one number itself is a perfect square number. Okay? So this answer that right now Xiomara gave us, that came from the development of this x plus 1 to the second power, which is called the perfect square trinomial, okay, makes or shows us one important relationship in algebra. So don't forget what means PST, which is perfect square trinomial. It's a trinomial, get it, from the product of a binomial multiply itself twice, as we have it with numbers. Now, what is the special property of this one? For example, what happened with 9? 9 has an exactly square root. So then the x squared plus 2x plus 1 will have an exactly square root 2. And at the moment to work with polynomial equations, which is topic of tomorrow, not at all a polynomial equation, right? But in essence, equation, sorry. It's a property that counts a lot. I think that you should write what PST means. Don't forget it. And we're almost done with the activities of today with the next page. Okay, we're almost finishing. And I want to show you the polynomial division. Just that there is a little problem here, and I mentioned this too. It's about how can I propose, it's about how do I propose the exercise. Is it okay if I leave it like this? What do you think? Because in the other exercises, I use something that maybe I'm not using here. What is it? And this is something like more of teacher than math, okay? Because I saw it in books like this, and it's not okay. Because mathematically, I'm representing other thing here. No idea? We may check the other exercises to see what is happening over there. Something happens with all the exercises here that's not happening here. What is it? Pónganle ojo al detalle. No?
Maybe you should use a vertical form.
Well, in this case, to divide, we haven't tried any method yet. I'm going to teach you this method right now. Okay? I'm going to teach you two methods, honestly, right now with this exercise. But there is a little trouble. Honestly, it's a trouble that is very, very, very simple to solve. And is that I'm not showing you a polynomial division right now. I'm sorry, I'm lying yourself if I do an exercise like this. I'm just asking you to make the division of this 9 with this x. Why? Because I'm not showing
Because
you.
there's no parentheses.
Exactly. And if you see the other exercises, parentheses, okay, and those, I don't show it. Be careful in mathematics, this counts, because this is what makes students get confused then. It doesn't look like it is, but this is what makes students get confused. Because then, suppose that they are trying to solve one combined operation, and they represent the things like this. It is practically answer wrong, next question. What is the half of 2 added with 2? What is the answer for this question? What is the half of 2 added with 2? You know, maybe you have a little trouble with this one or not. What is it?
3.
Is it 3 or what is it? I don't know.
Is that it says the half of 2. The half of 2 is 1. And then added with 2. So 1 plus 2 is 3.
That's the answer. And esta era una cadenita que se pasaban por ahí en el WhatsApp y alguien le ponía ese estado y usted lo contestaba y el chiste era que usted se equivocaba porque usted decía que era 2. Okay. The problem of not respecting the parentheses. That's what I'm saying. If you have it like 2 divided by 2 plus 2, for example, even some people say that this result is 0.5. There is a priority for the operations, and that's what I want that we understand, right? Why the parentheses are so important, because maybe here you can conclude 3 different answers when the answer is just 1. Come on, it's math. The answer is exact. Okay. So be careful with that little detail, and let's see how this division works. I will teach you one. I will teach you the long division. Okay? The long division will require we focus in leading terms every time. And we're going to apply the method we normally use, which is the division of, or which is the algorithm of the number division. Okay, so we're almost done. We're like 10 minutes to finish, and with this we may finish. The other method, which is called the synthetic, will be in your hands. I think it's synthetic with double Y. I think so. So here we go. What is my leading term in the divided polynomial?
The 3.
The x to the power of 3. Excellent. That's my leading term. What is my leading term in the divisor polynomial?
X.
The x. So here comes the tricky part. What should I multiply to x in order to make it x to the power of 3?
X squared.
Okay, if I multiply x times x squared, I will practically make x to the power of 3. Do you know into what consists the division algorithm? Last time I told you that too. Divide means cutting parts. But I told you something else. It's true. Don't remember those details? Well, the division consists into being looking for the way to eliminate the hundreds, the tens, and the ones. Essentially, that's what we do when we divide. Well, not always we eliminate that, right? Because there are some division that never ends. But in this case, in those exercises, the division ends. So let's see what happens if I multiply x squared times x and x squared times 7. What is x times x squared times x? What is it? Because we're going to multiply this. As you do it with when you divide, right? You put a number here and you multiply the number by the number over there. So what is x squared times x? It is x to the power of 3. Yes or no?
Yes.
And then what is x squared times 7?
7x squared.
And it's positive 7x squared. You're right. Now, the algorithm of that division consists into eliminate the ones, well, in order, right? If you have 100 numbers, so then the 100, the tens, and finally the ones. Something like that's happening here. Just that here I'm not working 100, tens, and ones. I'm working x to the third, x to the second, x to the one, and independent term, right? Non-variable expression. So check this out. We're going to make that subtraction of this one. What is x to the power of 3 plus 5x squared minus 8x plus 9 minus, of course, the parentheses, minus x to the power of 3 plus 7x squared. What will be the answer? And that's why I specify, look, minus and the parentheses, because this minus has an effect on this exercise. So x to the power of 3 plus 5x squared minus 8x plus 9. And remember that this negative sign change everything. This will be negative x to the power of 3 minus 7x squared. What will be the answer? Can you tell me? We have like terms. And what happened with those like terms? X to the power of 3 minus x to the power of 3?
Nothing. 0.
Thing 0. So practically they cancel. And this is the idea. Disappear the x to the power of 3. Try one division this way. And you will see that first step or the first multiplication you do will eliminate that 100 or that 1,000 you have at the beginning of that number. Okay? So here goes the next part. We have other like term to work with. We have the 5x to the second power and the negative 2x to the second power. What is it?
Negative, no, sorry. Yes, negative 2.
Yes.
Negative
Negative
2
2x to the
squared.
second power. You're right. So finally, I have the answer, negative 2x squared, and then the rest of the expression. As you can see, the algorithm is the same as when we work with numbers, just that now we are doing with variable expressions. So let's focus now in my new leading term. Who is my new leading term of this new polynomial? Because that's what you do, right? You subtract and then you have a new number. You start again the process. So my leading term is negative 2x squared. Essentially, I have to look for the way to convert my x into negative 2x squared. How can I do it? Multiplying it by, it have to be exactly the same expression. No idea. No idea? Because I want to give you one. Excuse me, by?
Negative 2x.
By negative 2x. Okay, Jerry, you got it. By negative 2x in order to make it negative 2x squared. I mean, negative 2x times x is negative 2x squared. You're right. So it will be negative 2x squared. And then we multiply the negative 2x times the 7, which will give us negative 14x, right? As you can see. Well, and again, we go with the same idea of subtract, because the algorithm of division looks for the way to eliminate the next um, positional system, or the next element of the positional system you have. It can be 100, a 10, or a 1, no problem. So what is negative 2x squared minus negative 2x squared? Or if you want it, do the procedure apart, as I did. Essentially, it's just work those like terms, being careful with the signs. So what happened with the first two? What is the subtraction of the same thing by the same thing? Negative 2x squared minus negative 2x squared. It's like they cancel, right? They cancel each other. We're going to have x squared, and then we're going to work with x. It is 0. It will be 0, I think so. 0, right? What about the next one? Negative 8x minus negative 14x. What will be the answer? Let's do it here. Negative 8x minus negative 14x.
6x.
Positive or negative?
Positive.
Okay. Positive 6x plus the 9. Okay, now exercise becomes easier. By what should I multiply the x in order to convert it into 6x? So easy, right?
By 6.
By 6. So then if I multiply this by 6, let's see what happens. 6 times x, 6x. Those will cancel each other. 6 times 7 is 42. So then at the end, I have to solve this subtraction. And finally, I conclude the answer of this exercise of division. Of course, like I say, division follows the same idea as the regular division you use with numbers. And the main idea here is eliminate every time the next degree expression. So focus on that idea. And the same happens when you divide. That's the idea of the algorithm. Making the number you're cutting in parts as many times as you can smaller. So what happened with 6x positive and 6x positive subtracting?
It's cancel.
They cancel each other. Then what is 9 minus positive 42? Is it negative 33?
Negative 33.
Yes.
Okay. So let me tell you that those exercises, the same happens with numbers, ends when you practically reach the same elements. And as you see, I place the x squared in the x squared position, the x in the x position, and the number in the number or numerical position, as you can see. So what will be the answer of this exercise? This one with reminder negative 23. Sorry, negative 33. Yeah, synthetic division is called synthetic for one reason. Should investigate why this is called the synthetic division, and I think this will be with some YouTube videos. So this is how the long division works, and well, it will be it for today, I think so. Just if there's any question, I can stay like some 2 or 3 minutes to help you with this last exercise that at the end, yeah, mix everything, as you can see. Questions about this long division? No? Yeah, I know we're so tired, but
I am trying to remember the synthetic form because I think that is better than the long one.
of course, but it's not working for all the ones. That's the problem. And this is something you should see in the assignment, right? That is about this one.
Okay.
Well, if there's no question, I think that we're gonna leave it until here. It's exactly 8 o'clock. I don't really like to take more time, so we can close the meeting right now. Okay, and start the class tomorrow. Ana Maria, you have a question?
Well, it's more a situation that I have. Is that, well, you know about what happened yesterday of Lima, and I was doing a lot of things, and I sent the homework, but the thing is that I sent the wrong homework, the wrong document.
Really?
So yeah, so I don't know if there is any chance that I can change the document.
What is the document for what homework?
Is that the last one, the one, the assignment 4,
Assignment 4. Okay,
the
I
one
was.
that we were supposed to send yesterday before 12.
Uh-huh. Okay,
So
I will look for the way to help you, and I will tell you. I think that tomorrow it will be.
okay.
I think it's okay.
Lee,
The only thing is that I was
I had
missing the score.
Excuse
It's
me?
the only thing. Sorry, Mister. Is it the only thing that I was missing was the picture of the score
Ah, okay. But you did it with your. Oh no, or no, right?
with
You
my
did
group?
it.
Yes, I do it with my group.
Okay. So
Mhm.
the score will be a GoPro.
Tell me.
Hello, Stephanie.
League, I had a problem too. Well, as Mercedes told you, I was running out of energy, and I
Uh-huh.
was the responsible for uploading the proportion homework,
Uh-huh.
and I didn't because I didn't have a computer, and I just had WhatsApp. I didn't had
But
like data for,
everybody has to upload it. I mean,
but
everybody should upload it.
I didn't send it because I had it on my computer.
Okay. Okay. So I got in your case. I think that all you have to do is like, well, send me an excuse to my mail, and I will read it, and then I will accept the job. No problem. But there's no excuse
Okay.
for this one. That's why everybody should upload the assignment, right? Because at the end you did it. There's one more question. I think it's Miss Karen.
Jeslik, I want to know something. For example, what happened if I sent the assignments 1 hour later? Because I, since all my assignments always appears
1 hour
minutes.
later. Don't worry about it. It's about the hour that works with the platform. It's not the same hour that works here in Honduras. I don't know why, but it's like that. Okay. Don't worry about it.
Okay, thank you.
Just if you don't send it, yes, right?
No,
Like,
I
like
sent,
happens sometimes.
but 1 hour later.
Okay, so don't worry about it. Okay, so my dear students, it will be it for today. I know we are so tired, so I hope to see you tomorrow with more energies. Okay, because last part of this will be about equations, and it becomes interesting. So see you next class, and go and rest a little bit. Okay, see you.
Bye.
Thank you. Bye bye.
Bye. Te escucho, Carmen.
Hola,
Hola.
el examen es el domingo, ¿verdad?
Siempre va a ser el domingo, sí. Con ese cerramos.
¿Qué cuesta el examen, Liz?
Cada examen va sumando, a ver, 25 entre 3 son como 8.33 cada uno.
Teacher, yo
Pero
quisiera hacer mi
no
examen
es el
como
examen final, Liz.
Disculpe,
No es
que
el
yo
examen,
quisiera
el
hacer
examen final.
no entiendo. Permítame, vamos a escuchar a Carmen y después escucho a Carolina. No las entiendo al mismo tiempo.
No es el examen final, Liz.
Sí, es el último examen que vamos a hacer. Recuerde que cada semana íbamos haciendo uno.
Ok.
Sí, 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 sí. Listo.
Es que creí que había un examen general, por eso lo pregunto.
No. La idea de ir haciendo los exámenes es que ya lo que se evaluó la semana pasada ya no se vuelve a evaluar. Esa es la idea.
Para que no nos enredáramos
Es
todas.
correcto, porque si no tendríamos las fórmulas de la semana pasada, lo que vamos a estudiar ahorita, entonces, mucha cosa. Carolina creo que tiene una duda también.
Sí, que quisiera saber cómo me fue en el examen.
Ah, ya el suyo ya lo revisé, voy revisando los de a pocos, ¿verdad? El suyo ya lo revisé, ahí sale la revisión en la plataforma.
Sí, pero es que como no sé en cuál me equivoqué.
Ahí yo le puse los cheques y todo. Usted me envió un documento como de 4 o 5 páginas, ¿verdad?
4, 2 páginas de, ajá, sí, de respuestas y 2 de preguntas.
Ya las revisó todas las páginas. Porque creo que las primeras páginas eran las preguntas y creo que las últimas eran las respuestas, ¿verdad? Creo.
Sí, así.
Ah, bueno, ahí en las últimas páginas está el cheque, donde falló. Ahí puede verificar.
Ah, ¿usted lo
Usted,
subió o cómo?
no, ahí mismo se verifica todo. Y ustedes lo pueden verificar también. Le iba a consultar. Usted fue la que utilizó el typer de Word, ¿verdad? Para subirlo. ¿O utilizó otro?
No sé, yo lo subí en PDF.
Pero lo hizo a mano y después tomó foto y me mandó la foto. Eso fue lo que hizo, ¿no?
Sí, sí.
Ah, ya, ya. Es que alguien lo hizo con un typer muy bueno.
Ah,
Bueno,
ok.
pues, pero ahí puede verificarlo. Ahí puede verificar su observación. Si no le aparece, pues
Ok, gracias.
ahí vemos cómo le va a aparecer. Bueno, pues feliz noche a todas y sería hasta mañana si Dios lo permite.
Buenas noches, Lick, gracias.
Noche,
Buenas
que
noches.
hasta mañana.